right? As I told you today, right, we are going to start the past paper discussion from today, right? Now we have completely discussed the grade 10 biology, chemistry, and physics sections, right? So from today, we will discuss the past paper questions from 2016 up to 22, right? I asked that at the very first day, I told you it is very easy to collect the marks for the exam, right? When we are doing the MCQ questions correctly, right? Because 1 mark for the one question in the MCQ paper means total 1 mark for the total mark from 100, right? So it is very easy to get the marks when we get more marks for the part 1 today, right? So from today we will discuss these things, and we have to discuss more and more past paper questions before the O-level exam, right? We have time now, right? Then we can very easily we can discuss those things, right? And the important thing that I have to tell you today, right? When we are doing the MCQ papers, right? We can cover the whole syllabus, right? To cover the whole syllabus, right? When we are doing the MCQ question, we have to gather information regarding all the 4 answers, right? That when we get the as an example, right? We get the first one, right? Before discussing the answers, I have to tell this one, right? This is the question, right? Normally, this is the question, right? And so, normally we are given 4 answers, right? Try to do in this way, right? When you are doing the MCQ, right? Especially the subjects like you are doing that geography, history, like that, right? So normally this is the question is given like this, and the 4 answers are here. If according to this one, according to our one, the first answers, the 4 answers are here: the HCl, H2SO4, right? H3COOH, and HNO3, right? These are the 4 answers, no? Right? What is our question is, what is the acid that is used for coagulation of rubber latex, right? That is the question. Right? There's a mistake put there. The first one and the second one is the same question, right? What is the acid that is used for the coagulation of rubber latex? Then what is the answer? Yes, tell me what is the answer? Yes. What is the answer, Pute? Yes, the third one, right? The third one, right? Normally, this is the answer, right? So that is that, as I told you, right? Not only to selecting the correct answer, right? We have to concern about the other 3 also, right? Because most probably for the next question, right? They can use these answers to make a question, right? So when we consider these 3 Pute, right? HCl, H2SO4, and HNO3, right? When we consider these 3, right? Oh, that is according to the question, right? Now, according to here, the HCl, H2SO4, and HNO3, these 3 are what? Strong acids, right? These 3 are strong acids. These are the most commonly used strong acids in the lab, right? Then we can make a note here, what? Strong acids, right? Strong acids. Then we have to know what are strong acids, right? What are strong acids? We have to remember the definition, right? Strong acids. They totally or they completely ionize the aqueous solution. Strong acids, they completely ionize in the aqueous solution, and they give H plus ions, and if it is in HCl, chloride ions to the solutions after completely ionizing in the aqueous solution, right? If it is in H2SO4, H plus and Cl minus. If it is sulfuric acid, H plus ions and sulfate ion. Right? If it is nitric, H plus ions and nitrate ion. Right? They completely ionize today, right? And they give these ions to the aqueous solution, right? Because they are in the aqueous solution, these ions are from the acid and from the water, right? There are H plus ions and OH minus ions in the solution, right? Like that, we can gather information about regarding this question today, right? This is only an example how we can gather other information related with this question, right? So there are many more questions like this that I think you can remember, right? Most probably from acids and bases, right? They ask the questions like this, right? As I remember, mostly the questions are from the acids. You know, so for the next year, we can guess that they can give a question from bases today, right? So we can write that one also, right? What are strong bases? Right? What are strong bases? Right? Then what is the definition for the strong bases? What are strong bases? Right? They completely ionize in the aqueous solution and they give OH minus ions and the related ions. If it is sodium hydroxide, they give OH minus ion and also sodium plus ions. Right? If it is potassium hydroxide, in the same way, they give OH minus ions and K plus ion. Right? As it is in the aqueous solution from water, there are H plus and OH minus ion. Right? Like that, we have to gather all the information related with this question today. That for this one also, we can put another note. Then if these are strong acids, right, and the strong bases, right, we have to know what are weak acids and weak bases, right? Weak acids and weak bases, right? We have to know that one also. Weak acids and weak bases. Then what is the definition? What happens when we add? What happens in the aqueous solution of weak acids and weak bases? And how they ionize? Are they totally ionized or not? Right? Normally, in weak acids and weak bases today, they are not totally ionized in the solution. They are not completely ionized, partially ionized in the solution. Let you know that one, right? Like that, when you are doing the MCQ papers, MCQ questions today, right? Try to do in this way, right? No need to write all the things, but the things that you remember regarding these questions, regarding the other three answers, you can make a note, right? When you are doing the first time, right? You remember some information regarding the three answers, right? If you are not remember anything regarding these answers, it is never mind today if it is in the first time. But you are doing the second time, then you can remind some things regarding the answers, right? When you are doing the next time, you can remind some other information like that. When we do several times past paper questions, right? We can collect all the things regarding the answer, right? It is very important, and this is very important when we are doing the biology questions, right? So when you are doing the MCQ questions, try to answer in this way, right? We will try, right? So the first and second one, the answer is the third one today, right? The acid that we use to coagulation of rubber latex, right? Then look at the third one. Which of the following is an amphoteric oxide? Amphoteric oxide. What do you mean by amphoteric? Right? They have both the acidic properties and basic properties, right? Sodium oxide, right? It is the oxide from an element of the first group, right? They have basic properties. We know that in the periodic table, right? You have a table also in the book, right? How the acidity and basicity differs along a period, right? In this way, in the periodic table, left-hand side, mostly they form, yes, basic oxides. Basic oxides. Then we find amphoteric, right? Then from here, they form what? Acidic oxide, right? So here, the amphoteric oxides, they have both the basic properties and acidic properties, right? Then what is the answer, Pute? Third one, aluminium oxide, right? Sodium oxide basic, P2O5, yes, acidic, and Cl2O7, that is also acidic, right? So the amphoteric oxide is aluminium oxide. Look at the fourth one, the catalyst which is used in the manufacture of sulfuric acid by the contact method. By the contact method. Yes, what is the answer? That is vanadium pentoxide. The fourth answer, vanadium pentoxide, right? Then, as I told you, for the first three, right? Yes, for the first three, you can write in which processes or in which uh, manufacturers, right? It used the copper, nickel, and iron, right? In that way, you can write the note, right? Look at the fifth one, put it. The number of lone pair electrons, right? Not lone pairs. The number of lone pair electrons around oxygen atom in a water molecule, right? Question number 5, right? And you have to remember this one, Pute, not like the when you are drawing the Lewis structures or the dot cross diagrams, right? It is given in the table also, right? When you are doing drawing the water molecule, you have to concern about the shape, right? There are shapes for each and every molecule as they are arranged in the three-dimensional view, right? For O-level syllabus, that is not mentioned, but here, when we are drawing the diagram of the water molecule, we have to concern that one because it is given in the book, right? You no need to remember the shape, but when you are drawing, right, you have to draw in that way, right? Then oxygen and the two hydrogen atoms here, right? So there's a special angle here. Don't concern about those things. When you are draw the water molecule, draw in this way, right? And there are two lone pairs here. If we draw the Lewis structure, use only the dots, right? Use only the dots here. Two lone pairs, right? Then the two hydrogen atoms, right? What is the question here? The number of lone pair electrons put there. Then what is the answer? Not lone pairs. They have asked the number of lone pair electrons. Then what is the answer? Yes, lone pair electrons. Yes, what is the answer? Tell me. Yes, second answer. The lone pair electrons. 1, 2, 3, 4. Right? If they have asked number of lone pairs, then two pairs put there. Right? Here they have asked the number of lone pair electrons. Right? So regarding this one also, you can gather some information. As an example, what we can yes, this is the water molecule, right? This is the water molecule, and there are two covalent bonds, and you can remember about the intermolecular bonds here, right? Then what are the properties of water? Right? What are the properties of water that water get because of these intermolecular bonds? Right? Like that, you can gather information about water, right? And regarding biology, right? What are the special properties of water? We discussed the coolant property. It used as a medium for the organisms, right? Solvent property, like that, right? And adhesive and cohesive forces, Right? Like that you can gather many information regarding water bottle. Right? Right? That is how we are doing the in a successful way. Right? We are doing MCQ questions. Right? Look at the next one, sixth one. Which of the following reactions is a neutralization reaction? Neutralization reaction. Right? Neutralization means acid react with the base and it forms the regarding the relevant salt and water. Yes, what is the answer? Third one to take. Right? Sodium hydroxide plus HCl and it forms the salt, sodium chloride and water. Right? And you are given some other, right? Look at the second one and the fourth one, right? Both are, yes, which type of reactions? Double displacement, right? Double displacement reaction, right? The first one, dissolving calcium oxide in water and it forms lime water or the slate lime, right? I think that you can remember double displacement. And what are the other three types of reactions? Chemical combination, chemical decomposition, and single displacement, right? Look at the seventh one. The chemical formula of the carbonate of an element M is M2CO3, right? What is the chemical formula of the chloride of M today? Chloride of M, right? The carbonate is given, that is M2CO3, right? So this is the valency of, right? So this is the valency of carbonate 2 and the valency of M is 1, right? M and carbonate here, right? We know the valency of carbonate is 2 put it, right? That comes for M and the valency of M comes for the carbonate and it is 1, right? So then we have to find the chloride of M, M1, chlorine 1. Then what is the chloride of MCl? What is the answer? The first one. Right? First one. Most probably you are given a question like this. Right? So don't mix up it. Right? Mostly that these questions are given for the first 20 questions. That means you can save time from the questions like this. Right? Because no need to argue and no need to do the calculations, right? Get the valencies in this way and apply it for the second one, right? Look at the eighth one, Pute. What is the number of oxygen atoms, right? Oxygen atoms in 22 grams of carbon dioxide gas, right? 22 grams of carbon dioxide gas. Question number 8. Right, carbon dioxide. Right, carbon dioxide, the relative molecular mass 44. Right, 44. That means in 44 grams of carbon dioxide, it contains, yes, how many carbon dioxide molecules today? How many carbon dioxide molecules? 6.022 into 10 to the power 23 molecules, right? Carbon dioxide molecule, right? And we know that in one carbon dioxide molecule, yes, how many oxygen atoms? 2 oxygen atoms are there, right? In one molecule, there are 2 oxygen atoms, right? So within 44 grams of carbon dioxide, right? This is carbon dioxide, right? Carbon dioxide molecule. Within 44 grams of carbon dioxide, how many oxygen atoms are there? Right? How many oxygen atoms? That is 2 into 6.022 into 10 to the power 23. Right? Double of this one because within one molecule, there are 2 oxygen atoms. Right? So, right? We have to multiply the Avogadro constant by 2 to get the oxygen atoms, right? This is carbon dioxide molecules, right? Oxygen atoms in 44 grams, right? Then what is the question here? In 22 grams of carbon dioxide, right? Half of this one. Then we have to divide this by 2. 23 and again divide by 2. They cancel out. Then this is the answer. Again, the Avogadro number of atoms, oxygen atoms are there, right? Avogadro number of oxygen atoms are there within 22 grams of carbon dioxide. So what is the answer? Is the second one, right? But I don't know that whether you have checked or not, right? In the marking scheme, the all given for this question, because there's a mistake, I think, in the Tamil medium paper, right? Normally, if there is a mistake in the Tamil medium or English medium or in the Sinhala medium, right? For all the mediums, the marks are given, right? As I remember, there's a mistake in the Tamil medium paper, right? So the answer is marked as all, but we can give the answer here, right? Look at the ninth one, right? Can you remember this relationship? I think that you can remember, right? There are many more questions regarding the Avogadro constant and the mole. Right? When we take any element, right? Any element, the mass of any element that is equal to the relative atomic mass, right? Relative atomic mass in grams, right? If it is magnesium, right? 24 grams, right? If it is carbon, 12 grams, right? If it is oxygen, 16 grams, right? It contains your Avogadro number of Avogadro number of atoms, right? Within 24 grams of magnesium, it contains this number of magnesium atoms, right? Then in 12 grams of carbon, right, it contains Avogadro number of carbon atoms. In 16 grams of oxygen, it contains this number of Avogadro number of oxygen atoms, right? And within all these, right, in 24 grams of magnesium, we say it contains 1 mole of magnesium atom. Within 12 grams of carbon, it contains 1 mole of atom. Here also same, in 16 grams of oxygen contains 1 mole of atom. Right? This is regarding with the atoms today. Right? If it is in molecules, like carbon dioxide, I think you can remember how to get the relative molecular mass, right? 12 plus here 32. 12 plus 32, 44 grams. If it is water, H2O, right? 2 plus 16, altogether 18. Right? We have to take the mass that is equal to the relative molecular mass in grams. Right? In grams, then it contains just this number. Avogadro number of molecules today. Avogadro number of molecules. That means within 44 grams of carbon dioxide contains this number of carbon dioxide molecules. Right? 18 grams of water contains Avogadro number of water molecules. Right? And 44 grams of carbon dioxide means 1 mole of carbon dioxide molecule. And 18 grams of water means 1 mole of water molecule. Right? That is the relationship today. This is only thing that you have to remember. Right? You are given the relative atomic masses, and by adding the relative atomic masses, you can calculate the relative molecular masses, right? No need to remember those values, right? Normally for the MCQ paper also, right, you are given the relevant atomic masses. Right. Look at the ninth one. Three properties of a particular element are given below, right? That normally that if you are given the questions like this one, the statement questions, right? You have to concern about those things, right? Look at the statements with they occur in crystalline form as well as in amorphous form, right? In our syllabus, there are only two elements regarding with this one. Occur in crystalline form and as well as amorphous form. What are the two elements? Carbon and sulfur, right? Only we are discuss those two, carbon and sulfur, right? Look at the second one. Insoluble in water, but very soluble in carbon disulfide solution, solvent, right? And look at the third one. Burns with the blue flame in air. Burns with the blue flame in air. Then here also, for the first one I told you, for the amorphous forms and crystalline form, sorry, only we have carbon and sulfur, right? So it should be, uh, the answer should be one of these two, right? We don't. Look at the second one. Insoluble in water, but very soluble in carbon disulfide solution, solvent, right? Then look at the third one. We can get the answer from that one. Burns with a blue flame in air, right? As I told you, right, in our syllabus, only there are two flames that gives colors. In magnesium, you can write those things today, right? In magnesium and only in sulfur. Magnesium, it gives a bright white color flame, and sulfur, it gives a blue color flame, right? So we can get the answer from the third statement, it should be sulfur. Then what is the answer? Fourth one to take, right? And you have to write this one. When we burn sulfur in air, right? If you ask, right, for the structured paper or they say paper, write down two observations. Write down two observations you can collect when you burn sulfur in air. Yes, what are the observations to take? It gives a blue color flame and the unpleasant smell, right? That is due to sulfur dioxide. You can't write the sulfur dioxide is releasing or sulfur dioxide is foam like that. You have to write only the observation, right? From these observations, we can confirm that there's a chemical reaction is going on, right? But for the observations, what are the things that you can write? The formation of a precipitate, right? Formation of a precipitate, the color of the flame you can write, evolving of gases, only you can write. Gas bubbles are evolving in that way, right? If there is a temperature change, you can write that one, right? If there is a color change in the solution, you can write that also, right? And the color of the flame, temperature changes, evolving of gases or the air bubbles, right? Making a precipitate, the color changes in the solution. Those things you can write as the observation, right? So when we burn sulfur in air, it gives a blue color flame and that unpleasant smell. This is smell, right? And when we burn magnesium in air, yes, what are the two observations? There also we can get two observations. It gives a bright white color flame, and what's the other one to take? It forms it remains a white color powder. You can't write magnesium oxide, right? For the chemical equation, we write magnesium plus oxygen, magnesium oxide. That is okay, right? But if you ask to write an observation, you can't write the formation of magnesium oxide, right? Because by looking at that one, we can't say that is magnesium oxide. Observations means put it, the things that we can gather to our five sensory organ. So only we can see there's a white color powder, right? So for the observations, you have to write white color powder is formed, right? Now, question number 10. Which of the following substances can be mixed with water to make a homogeneous mixture? This is a question from grade 11, right? But never mind, right? Heterogeneous mixture. You know that we can divide or we can categorize the mixtures as homogeneous and heterogeneous, right? Homogeneous, the composition is same throughout the solution, right? And in heterogeneous, the composition is different throughout the mixture, right? And you have to remember some examples, right? Then what is the heterogeneous one? Put a fourth one. Because wheat flour does not dissolve in water completely, right? Copper sulfate, ethyl alcohol, sugar, right? They completely dissolve in water and make a homogeneous mixture, right? When we dissolve these copper sulfate, ethyl alcohol, sugar or salt, they totally dissolve in water and the composition becomes same throughout the solution. Solute, solvent and solution. I think you can remember these things, right? Solute, we dissolve the solute in a solvent, right? And it makes the mixture. We name it as the solution, right? Solution, right? So here it forms a heterogeneous mixture when we dissolve wheat flour in water, right? The fourth answer. Say the question like same is given in the 16th one put there. As I remember, it is in 17, right? This one from the question number 10 from the 2016 and this is from the 17. Look at that, the same questions are repeating, right? With only a few changes, right? We will see. Look at the 11th one. Which of the following oxide is basic? I told you that in the very first one, right? The second, the third one, they have asked the amphoteric oxide. Now they have asked what is the basic one, right? Yes. What is the basic one, Puti? I told you the elements from the left hand side. Most probably the elements in the first group and the seventh group, they form the basic oxide, right? And the elements in the right hand side, they form the acidic oxides. Then what is the answer, Puti? First one, magnesium oxide. Again, we can remember magnesium oxide. When we burn magnesium in air, it forms magnesium oxide and it is a white color powder like that, right? Aluminium oxide, we discussed, it is an amphoteric one. Sulfur dioxide, it is an acidic one, right? Look at the 12. The number of electrons and the number of protons in an aluminium 3 plus ion are respectively. The atomic number is given, Puti, right? Aluminium 3 plus ion. Aluminium 3 plus ion. The atomic number is given. Question number 12. Atomic number 13. Atomic number 13. Then we can write the electronic configuration. 283. 283. Then there are how many electrons, Puti? 13 electrons. Right? 13 electrons. So, to get the stable configuration, right, what aluminium is doing is, right, they remove these 3 electrons in the last energy level. Then they get the electronic configuration of, neon, right, 2,8. Right, after removing these 3 electrons in the last energy level, right, before removing the 3 electrons, how many electrons are there? 13 electrons. How many protons? Put the atomic number is 13. Then there are 13 protons. Right? No need to think about the neutron. Right? Then after removing these 3 electrons, it forms the Al3 plus ion. Al3 plus ion. Then now how many electrons, Puti? After removing these 3, now there are only 10 electrons. Only 10 electrons in Al3 plus ion. How many protons are there? Is there a change in the number of protons? No, today. Right? You have to remember. Right? They do all the atoms, right? Except the noble gases, right? They make the bonds to get the stable configuration, right? They make the bonds, whether the ionic or the covalent bonds, they make the bonds to get the stable configuration, right? So for making bonds, only the electrons are participating, right? There is no change in the number of protons or the number of neutrons, right? They remain constant. So the number of protons is again 13. Then what is the answer? The number of electrons and the number of protons respectively. Electrons 10, protons 13. First answer, right? Al3 plus ion, and it gets the stable configuration of neon putty, right? Get the configuration of neon, right? And the all the other atoms in this period, right? Sodium, magnesium, aluminium, no, right? Then sodium forms the Na plus ion putty, right? And magnesium forms the Mg2 plus ion, right? Then as here, aluminium forms Al3 plus ion, right? Now all these have how many electrons? All these have how many? 10 electrons. Okay. Now all these have 10 electrons. 10 electrons. That means all these three, not these three, sorry, these three put sodium plus ion, Mg2 plus ion, Al3 plus ion, they get the configuration of neon, right? The questions can be given in this way also, right? So the elements in the same period, after removing the electron, they get the configuration of the noble gas in the relevant period, right? So you have to remember these things. And the elements in the right hand side, after obtaining the electrons, they get the same configuration today, right? Now 13. A certain covalent compound is completely ionized in water. A question like that, right? Which of the following could be this compound, right? According to the first one, no? We discussed that in the first and second one, no? Yes, right? A certain covalent compound, right? Covalent compound completely ionized in water. Which of the following could be this compound? What is the answer, Pute? Yes, what is the answer? Tell me what is the answer for the 13? Completely ionized in water. Yes? Yes. Right, HCl. It is an strong acid. What is the first one? Put ammonium hydroxide or liquid ammonia, ammonium hydroxide. Right there. It is a weak base. Put it is a weak base, ammonium hydroxide. So it is not completely ionized. It is partially or incompletely ionized in water. Right? Incompletely ionized in water. I will tell that one also, right? Right, all the things that we are discussing regarding one each and every question you have used for the 23 exam, right? We are ready for that one, right? Look at this one, with the ammonium hydroxide. It is a weak base, right? It is a weak base, right? So it is not completely ionized in water or in the aqueous solution. Right, aqueous means in water, right? It is not completely ionized. So what are the ions in this solution, Putte? If you ask to write that one, it is partially ionized. It is a base, so it gives OH minus ions to the solution, right? So there may be, it is partially ionized, no? Then some amount of ammonium hydroxide ionized in the solution. So there are ammonium ions and OH minus ions in the solution, right? And in water, no, then from water, this is from NH4OH, right? These are the ions from ammonium hydroxide, NH4 plus and OH minus, right? Then what are the ions from water? Yes, H plus and OH minus ions, right? So OH minus ions from ammonium hydroxide and from water also, right? And as this is a weak base, it is not completely ionized. So in the solution, there are ammonium hydroxide molecules also. Right? Because it is not completely ionized. Right? So you have to remember this one for the weak bases and weak acids today. Right? If it is a strong one, like HCl, H2SO4, right? And nitric, right? So these things, there are no HCl, no H2SO4, no nitric molecules in the solution, right? They completely ionize to H plus and the 11 negative ion, right? In strong bases also same Putte, right? There are no sodium hydroxide molecules in the solution, right? Na plus and OH minus, K plus and OH minus. But here we can find NH4 plus, NH4OH, ammonium hydroxide molecules in the solution, right? Then copper sulfate, right? It is a salt. And what is the color? Blue color, copper sulfate and H2CO3, carboxylic acid, right? 14. The composition of a glucose solution in terms of mass and volume is 90 grams per cubic decimeter. Right? What is the concentration of that glucose solution? The relative molecular mass is given. Right? They have made the question somewhat easy for us. Right? If they are not given the relative molecular mass, if they are given the relative atomic mass, then we have to calculate the relative molecular mass also, right? But directly they are given the molecular mass today, right? The composition is given regarding mass and volume, right? Regarding mass and volume. Question number 14, regarding mass and volume, that is 90 grams per cubic decimeter, right? They have asked what is the concentration of that glucose solution. Normally we are given the concentration by moles per cubic decimeter. So we have to get the answer for this one. Now the cubic decimeter is okay today, right? So this is the mass in 1 cubic decimeter, right? Concentration means we have to find how many moles are there in 1 cubic decimeter, right? So what we have to do is, this is the mass today, right? We have to convert it into what? We have to convert this part, gram part, into moles. Gram part into moles, right? We know this one. Number of moles equal mass divided by molecular mass. We have to find this one, right? We have to find this one. Then mass is given, that is 90 grams, and the molecular mass is given, that is 180 grams per mole. Just 2 gram to gram. Half means just 0.5 mole. then directly we can write it here. Right? Then what is the answer? 0.5 moles per cubic decimeter. Second answer. Right? You have to remember this one. And concentration means number of moles in a unit volume. Concentration, number of moles in a unit volume. Most probably, we are given the concentration in moles per cubic decimeter. Moles per cubic decimeter. Here you have remember this one, Pute. 1 cubic decimeter means, yes, how many cubic centimeters? 1000. This one. Right? And this one. 1 milliliter means 1 cubic centimeter. Right? You have to remember these relationships today when you are answering the question. Right? So directly we can get the answer by using this one. Number of moles equal mass divided by the molecular mass. Right? Very easy. Right? So the most probably that you are given these calculation type questions after the 20. Right? So that is why I told you we have to save time from the first 20 questions for the rest of the first paper. Right? For 40 questions, we are given 1 hour today. Right? There may be many calculations and at the last part of the paper, right? There are some questions that we have to think and to do the calculations to apply the theories or the principles that we have learned. So we have to save time for those, right? Then the first 20 questions, from the first 20 questions, we have to save time for them, right? Right, this one okay. Question number 15. The final products of the reaction of hematite Fe2O3 with carbon monoxide gas in the temperature range. The temperature range is given. Right, I think you can remember all the equations regarding the extraction of iron. Right. The question is from one equation from those. Right. Yes, what are the final products when hematite react with carbon monoxide? Yes, that is iron and carbon dioxide. The first answer, ferrous and carbon dioxide. Right? You have to remember these things today. Right? Hematite, Fe2O3. This is the process or this is the step where the hematite is extracted. Right? Fe plus CO2. Right? You have to balance the equation. Right? And right, for the calculation part also, you can given these questions. Right? From this number of grams, right, it can obtain this number of grams. Then from this number of grams, how many grams or how many moles you can contain. You have to get the ratio, the mole ratio. First, you have to balance the equation, right? It is very easy to remember these equations, Pute. Right? Write the equation several times, then very easily you can remember the equation. Right? So you have to, there may be questions to get the relationships in this way. Right? For the structure or the essay paper also, most probably the questions are given like this. Right? So for the MCQ paper also, they can give a question like this. Right? So you have to remember this one. Right? This is the step where the iron is extracted. Right? Right? The question number 16. Which of the following is a homogeneous mixture? In the previous one, they have asked about a heterogeneous mixture. Now, homogeneous mixture. Right? What is the answer? The second one. Right? Ethyl alcohol and water. All the other three, wheat flour and water, heterogeneous, coconut oil and water, we know, right? And clay and water. all the three, 1, 3, and 4, heterogeneous mixture, and ethyl alcohol and water, it is a homogeneous one, right? Again, a question, the statement type question, right? You are given three statements. Look at A. Catalyst increase as well as decrease reaction rates, right? B. Though catalysts take place in the chemical reaction, they are not consumed during the reaction. They are not consumed. C. A small amount of the catalyst is adequate for a large amount of reactant. Yes. What about the three statements today? Look at the first one, right? You have to be very careful about these statement type questions. If you are given the words only, always, like that, right? You have to concern about those things, right? Catalyst increase as well as decrease reaction rate. Decrease reaction rate, right? As we learn, right? We learn in that way today. Catalyst can increase or decrease the reaction rate. But now, right? In the textbook, it is given if they decrease the reaction rate, we name them as, here's what, inhibitors. They are not catalysts, they are inhibitors. So we say always, if you are given the sentence like that, always catalysts increase the reaction rate. Is it right or wrong? Always catalysts increase the reaction rate. Yes, it is correct, Putu. Right? According to our textbook, they say catalysts increase the reaction rate. Right? There are some substances that decrease the reaction rate. We name them as inhibitors. Inhibitors. So the first statement is wrong. Right? As well as decrease, that is wrong. Right? Look at B. Though catalysts take part in the chemical reaction, they are not consumed during the reaction. Yes, that is correct. They are not consumed. The mass remains constant before the reaction and after the reaction. Right? What only we say, the physical state can be changed today. Right? Physical state can be changed during the reaction. Right? But it remains constant in the mass. Right? They are not consumed. They are not used in the reaction. Look at C. A small amount of the catalyst is adequate for a large amount of reactant. Yes, that is correct. Then B and C only. A is wrong. Then second answer to take B and C. 18. Again, regarding with the ion extraction, right? Which of the following oxides does not take part in the extraction process of iron? Calcium oxide. Calcium oxide, can you remember? Is it involving in iron extraction? Yes, yes, okay. Right? We, as a raw material, we use calcium carbonate. Right? We use calcium carbonate. Right? You can gather some information here. Right? How it appear calcium oxide by the decomposition of calcium carbonate. Right? We do not use calcium oxide. Right? As a raw material, we add calcium carbonate, limestone. Right? So due to the high heat, calcium carbonate decomposes into calcium oxide and carbon dioxide. Then calcium oxide is there. Magnesium oxide, right? Then carbon dioxide, yes, carbon dioxide is there. Oxide, right? And silicon dioxide is there, right? As the impurities we get it. Then, right, the magnesium oxide is not involving in the ion extraction process. So what is the answer, Pute? Second one. Second one. Yes. Look at the question number 19. The relative molecular mass of the hormone adrenaline is 183. Right? The relative molecular mass is given. Thus, X in the relationship represent. Yes. This is the relative molecular mass of adrenaline hormone. 183. How we get this one? How we obtain this relative molecular mass? By dividing the mass of an adrenaline molecule by what Pute? Yes, how we get the relative molecular mass? Relative molecular mass. Yes, by dividing. Yes, what we have to write here? Yes. Yes. 1/12 part of the mass of what? Carbon 612 atom or the carbon 612 isotope. Right? 1/12 part of the mass of carbon 612 atom. Right? For this one, we can use another term for this one today. What is that? Instead of this part, it is not given in the question. Right? Instead of this one, they can make the question by using that also. Yes. 1/12 part of the mass of carbon 612 atom. Yes, instead of this part, we can use another term. What is that? Yes, can anyone tell me? Instead of this part. Yes. How we name this one? 1/12 part of carbon, the mass of carbon 612 atom. There's a single term we can use instead of this one. Yes. Yes, atomic mass unit. Very good, right? Atomic mass unit. Right? So they can give a question regarding using this one also. Atomic mass unit. Right? Atomic mass unit means the calculated value of this one. If you are given the atomic mass unit, no need to get the 1/12 part of that put it. That atomic mass unit means they have taken the 1/12 part of the mass of carbon 612 atom. Right? So instead of this part, we can use this one also. Then what is the answer? Second one. 1/12 part of the mass of carbon 612 atom. Right? They can give a question by using this. Right? Very good question in the question number 20. Right? Consider the following aqueous solutions of equal concentration. Concentration is equal, right? Sodium hydroxide is there. Again, ammonium hydroxide. Sodium hydroxide, it is the strong base. Ammonium hydroxide, weak base. CH3COOH, weak acid. HCl, strong acid. Then select the option which indicates the increasing order of their pH value. Increasing order, right? Increasing order of pH value. Increasing order of pH value. Question number 20. Right? pH value. Right? Normally we know that pH value is from 1 to 14. Right? So, how it spread through strong acids, weak acids, right? Weak bases and strong bases and the neutral solutions, right? I will write like 1 here, 7 here, 14 here, right? So if the pH value is less than 7, less than 7, we know this one, no? Right? If the pH value is 7, we say they are neutral, right? Like water, neutral, right? If the pH value is between these or less than 7 means 1 to 6. Less than 7, they are acids. Right? If it is higher than 7, right, like from up to 18 to 14, yes, they are bases, right? Then another thing that we have to consider, right, acids, there are weak acids and strong acids put it, right? If the pH value is 1, 2, 3, 4 like that, we say they are, yes, strong acid, right? So the pH values are here. Strong acids are here and the weak acids are here. Right? Strong acids and weak acids. Then what about the bases today? Yes, what about the bases? In bases, right? In bases, the weak bases are here. Weak bases and the strong bases are here. Right? Strong bases are here. Right? So from 1 to 14, right? Acidic properties decreases. Right? Acidic properties decreases and the basic properties increases. As 1 to 14, the pH value, right? Acidic properties decreases and the basic properties increases. So we can find the strong acids here like HCl, H2SO4, HNO3, like that. Strong acid. For the weak acids, we use ammonium hydroxide, or we can say the liquid ammonia. For vessel, right? Vessel. Weak acids, no, like this, CH3, COO, right? For the weak bases, like ammonium hydroxide, right? For strong bases, we can write like sodium hydroxide, potassium hydroxide, next. Right? This is how the pH value differs, right? Then what is the answer? Select the option which indicates the increasing order of the pH value, increasing order. Then first it should be the strong acid. What is that? HCl. D should be come first. D. Then weak acid there. CH3, COOS. Then C, D, C. Then weak base, ammonium hydroxide, B and A. What is the answer? Put it. Second one. Second one. Right? It can be given the questions in this way. Right? Or with some differences of this one. Right? A question is that we have discussed. What is the option? 21, right? What is the option that correctly indicates all the species contained in an aqueous solution of hydrochloric acid? Put it. Hydrochloric acid. We know that hydrochloric acid, HCl, is a strong acid, right? So it is completely ionized in the aqueous solution, completely ionized. So there are no HCl molecules in the solution, no HCl in the solution. So we can cut the first, we can cut the third, and we can cut the fourth. Then at once we can get the answer. It should be the second one, right? If it is a strong one, maybe an acid or a base, right? There are no acid or base molecules in the solution if it is a strong one, right? So in the first one, third one, and the fourth one, there are HCl molecules. So they are wrong. Then what is the answer, Pute? Second one. H plus ions, OH minus ions, Cl minus ions, and water molecules are there, right? Very easy one, 22. The total number of atoms in 1 mole of carbon dioxide molecule, 1 mole of carbon dioxide molecule. Total number of atoms. right? Not the carbon dioxide molecules, right? Look at this one. You have to concern the words, each and every word given in the question today, especially in the MCQ ones, right? Otherwise, you select the wrong answers. Because the wrong answers that we make, they are given as the answer, right? That is the way, yes. That is the way of right making the MCQ question, right? For the MCQ questions, right? Think that when we are doing a calculation, right? For the correct answer is 10, right? This is an example, okay, right? There is a calculation, right? The correct answer is 10, right? If we do any mistake in the calculation, right? We get the answer as 20, right? If we do any mistake. So they give the 20 as an answer, right? So if we get the answer with the mistake as 20, the answer is there, then we mark that one, right? If 20 is not among the 4 answers, then again we try, no, right? Then if the answer is not in the 4 options, right? Then we try again, right? But they find what are the mistakes it can be happen, then they give those answers, right? So if we do not check twice, right, our answer will be wrong, right? So that is why we say, right, after marking all the answers, you have to check again, right? So to recheck, we have to save time, right? That is why we have to practice more and more, right? Here, look at the question number 22. What is the question, Budin? The total number of atoms in 1 mole of carbon dioxide molecule, right? Total number of atoms, right? Carbon dioxide within 1 molecule, how many atoms are there? How many atoms, Budin? Yes, there are 3 atoms, 1 carbon atom and 2 oxygen atoms, right? Then altogether 3 atoms are there, right? So within 1 mole of carbon dioxide, right? Within 1 mole of carbon dioxide molecule, there are this number of, so we can say Avogadro number of carbon dioxide molecule, right? Avogadro number of carbon dioxide molecules are there in 1 mole of molecule, but we have asked the total number of atoms. Then we have to multiply this by 3 Pute. Right? The same question asked, as you remember, that the number of oxygen atoms. Can you remember that one? Number of oxygen atoms. Here they have asked number of total atoms Pute. Right? If you have the number of carbon atoms, then it is same. This part. Right? Did you get that? Most probably they have asked from carbon dioxide or from water. Right? Very easy to take. So what is the answer? First one. Look at the next one. 23. Hydrogen sulfide H2S. Right? React with sulfur dioxide SO2 according to the following balanced chemical equation. They are given the equation. Right? Balanced chemical equation is given. The reaction between hydrogen sulfide H2S plus sulfur dioxide. H2O and 3 sulfur 23. Right now. Right, already this balanced. The amount of moles of sulfur dioxide that reacts with 1 mole of hydrogen sulfide is, right? According to the equation put there, right? 1 hydrogen sulfide, right? The ratio is 2 to 1. 2 to 1, right? Two H2S molecules react with one sulfur dioxide molecule and forms two water and three sulfur, right? But they have asked the amount of moles of sulfur dioxide that reacts with 1 mole of hydrogen sulfide. With 2 moles of hydrogen sulfide, it reacts 1 sulfur dioxide. Then between 1, yes, how many moles? 0.5. If this becomes half, this part also should become half. Right? If it is 2 to 1, then 1 to half. 0.5. What is the answer? First one. First one. Right? Now, right? 24. Again, a statement like question. Consider the following statements about the compounds carbon dioxide and sulfur dioxide. Right? The three statements are regarding these two pute, carbon dioxide and sulfur dioxide. Right? A, they are acidic oxides. They are acidic oxides. Yes. When they dissolve in water, they form acid. Carbon dioxide, it forms H2CO3, and sulfur dioxide, it forms sulfuric acid. They exist as gases under room temperature. Yes, they exist as gases. Carbon dioxide is a gas, sulfur dioxide is a gas, right? They are colorless. Yes, they are colorless today because they are in our atmosphere, right? There are no colors in the atmosphere because of carbon dioxide or sulfur dioxide. So they are colorless, right? So the true statements are yes, A, B, and C. All are correct. All A, B, C are correct, right? Then look at this one, right? That normally when they are given these the table-like questions today, right? You have to be very careful. Right? You have to be very careful because you have to concern about the all the three given. Here the three figures are given as X, Y, Z, right? So you have to select the correct answer regarding these three, right? The Lewis structures of the hydrides of the three elements X, Y, and Z are given here. Which elements in the table are represented by X and X, Y, and Z? All these three are hydrides, right? We have to select what is X, what is Y, and what is Z. Right? Look at that. Right? If we are very thorough about the Lewis structures, right? Normally, if you are given the Lewis structures today, right, they are given from the structures that we are that is given in the textbook, right? So if you are very thorough about the textbook, very easily you can find the answers, right? Look at the first one, put a X is in the middle and there are two hydrogen atoms, right? And there are two lone pairs in the X, two lone pairs, right? Then what is that? It should be oxygen. This is water molecule, right? Look at the second one, Y. It combined with three hydrogen, put a three hydrogen and only one lone pair with the Y. Then it should be, yes, should be nitrogen. This is NH3. Ammonia is given, right? Then look at the fourth one. There are four bonds with four hydrogen atoms, right? It makes four bonds. Then it should be in the fourth period. Then Z should be carbon. X should be oxygen. Y should be nitrogen. And Z should be, yes, carbon. Then what is the answer for the second one? Oxygen, nitrogen, and carbon. Oxygen, nitrogen, and carbon. Right? A question. Right? Look at the 26. The number of electrons and the number of neutrons in the ion indicated by the symbol. 1123 sodium plus iron respectively are. Right? What is the iron here given? Sodium plus iron, right? Atomic number 11 and the mass number 23, right? The number of electrons and the neutrons we have asked today, right? This is atomic number, that means the number of protons, right? The number of protons does not change, right? So in the iron also, yes, there are 11 protons, right? Then how many electrons put a? The mass number is given and the atomic number also given, right? I told you, when making bonds or when making iron, protons and neutrons, right, they do not participate for making bonds. Then the number of protons remain constant and the number of neutrons also does not change. Then 23 minus 11. What is the answer? 12. There are 12 neutrons. Then how many electrons put there? How many electrons? Right, the atomic number 11, then 11 protons, 11 electrons, 2, 8, 1. The electronic configuration, right? It removes this electron. It removes this electron, then form the Na plus ion. Na plus ion. Then how many electrons are there now? 10 electrons are there. 10 electrons are there. And it gets the stable configuration of neon today. Right? Then the number of electrons 10 and the number of neutrons 12. Third answer. Third answer. Right? Look at this one. Which following molecule is composed of the highest number of atoms? Highest number of atoms. Question number 27 today. Right? CO4, H2SO4, CO, H2 twice. This is the formula for urea, right? Right. How many atoms are there? 1 carbon here, 3 hydrogen. 3 plus 1, 4, 5, 6, 7. Right. All together, 7 atoms are there. Right here, 1 carbon and 4 Cl. Right. 4 plus 1, 5 atoms are there. Right here, 2 hydrogen. Then 2 hydrogen, 1 sulfur, all together 3. And here 4 oxygen. Then all together 7 atoms are there. Look at here. 1 carbon, 1 oxygen. How many nitrogen? 2 nitrogen. And how many hydrogen to take? 4 hydrogen. Right? Then 4 plus 2, 6, 7, 8. Right? All together, 8 atoms are there. Right? Then this is the answer. This contains the highest number of atoms. Fourth answer. Right? This is the formula for urea. Right? It is also most probably used. Right? No need to remember this one. Right? That if there is a calculation or any question, normally they are given the formula. Right? Look at question number 28. The relative atomic mass of iron 56. The relative atomic mass of iron is 56. Right? Thus, which of the following statement is correct statement? Right? We have to find the correct one. The mass of an iron atom is 56 grams. The mass of an iron atom today. No. Is the mass 56 equal to the mass of one atom? No, that is wrong. Not one atom today. Right? Not one atom today. Right? Regarding the first one, what should be corrected? Right? the mass of an iron atom is 56 grams. No, that is wrong. Not one atom. How many atoms would take? Yes, this number. The mass of Avogadro number. That the mass of Avogadro number of atoms. Yes, that is 56 grams. Not one atom would take. Right? So it should be corrected in this way. Right? So for the next exam, they can give a sentence in this way. Right? That is why I am writing. Now, look at the second one. A mole of iron contains 56 iron atoms. A mole of iron contains 56 iron atoms. Is it correct? No. Then 1 mole of iron. 1 mole of iron contains how many atoms to take? This number of atoms. Avogadro number of atoms. Right? Avogadro number of atoms. Not 56 atoms. Right? Look at the third one. Right? The mass of Avogadro number of iron atom is 56. This one. The corrected one from the first one. They are given as the third one. Right? In the first statement, there is a mistake. They corrected that mistake and given as the third one. That is the correct statement. Right? Then we look at the fourth one also. The mass of 56 iron atom is Avogadro number of grams. No, that is wrong. Right? The mass of Avogadro number of atoms is 56 grams. Again, this one. Right? So the correct answer is the third one. Right? Third one. Look at the question number 29. Which of the following molecules is made of 2 covalent bonds? 2 covalent bonds. We'll do. Right? This one okay, no? Right? Very careful about the statement type questions. Right? 29 today. 29 first one, Cl2. Right? What is the bond? Cl, Cl. Only one bond is there. We have to find the 2 covalent bonds. Right? CH4. In this way. Right? 4 bonds are there. Look at the third one. HCl. Same as this one. 1 bond is there. Right? Look at the fourth one. H2O. 4 is here. And there are 2 bonds. 2 covalent bonds. Right? Then what is the answer would be? Fourth one. Fourth one. Right? Look at the question number 30. Given below is the balanced equation relating to the decomposition of potassium permanganate. Decomposition of potassium permanganate. Right? Now, how much is the amount of moles potassium permanganate that should be decomposed to produce 3 moles of oxygen gas? 3 moles of oxygen gas. Yes. This one okay now, right? We have to use the balanced chemical equation for to get the answer today. Right? Already they are given the balanced equation. 2KMnO4 30. Then the side plus go to right. This is the equation now. Right? Okay. How much is the amount of moles of potassium permanganate that should be decomposed to produce 3 moles of oxygen gas? We have to get the ratio between potassium permanganate and oxygen potassium. Right? By 2 moles of potassium permanganate, it gives 1 mole of oxygen. Right? We will write in this way. The ratio between these two, we have to get the relationship. Right? By 2 moles of, according to the balance equation, by 2 moles of potassium permanganate, it gives 1 mole of oxygen. 1 mole of oxygen. Right? They have asked to obtain 3 moles of oxygen. Right? 3 moles of oxygen. How many molecules of, or how many moles of potassium permanganate that we have to decompose. Right? This side become, yes, increase by 3 times. Then here also we have to multiply by 3. That means 6. Right? Or we can get the relationship in this way. Right? It gives 1 oxygen by 2 moles. Right? 1 oxygen is given by the decompose of 2 moles. Then by to get 3 oxygen. To get 1 mole of oxygen, we have to decompose 2 moles of potassium permanganate. Then to get 3 moles of oxygen. 2 into 3, that means 6. Right? What is the answer? Fourth one. Fourth one. And there are some important things regarding this one. Can you remember? The decomposition of potassium permanganate today. Right? Yes, this is the process that most probably we use for the oxygen production. Right? Producing of oxygen gas. Right? Then you can find the properties of oxygen gas. Right? Uses of oxygen gas and the collection method of oxygen gas. Right? And there you can remind other two also, hydrogen gas and carbon dioxide gas. Right? And you have to remember this ratio today. Right? Here they are given the relationship between the moles. Right? They can give the relationship with the grams also. Right? When we decompose this much of grams of potassium permanganate, like that. Right? So that normally here that you are given the balanced chemical equation, right? If it is in the structured or they say paper, right? If they ask you first, if they ask to write the balanced chemical equation, so we have to know this one also, right? So remember these things, right? Give me 1 second. Right. Then question number 31 to take. Right. Consider the following substances. Right. There are three statements given. Right. A, solid sodium chloride crystal. Right. Solid crystal. B, molten sodium chloride. C, aqueous sodium chloride solution. D, molten, C, aqueous. Right. Which of the above conduct electricity? Which of the above conduct electricity? We discussed these things regarding the ionic compounds and the covalent compounds. Right? We say the ionic compounds in the molten or the fused solution or the aqueous solution, they conduct electricity. Right? So B and C. Right? B and C solutions conduct electricity. What is the answer? Put a third one. Right? Not the solid sodium chloride crystals, molten or the aqueous ones, they conduct electricity. Right? It's a feature of the ionic compound. Right? You have to remember what are ionic compounds, what are covalent compounds, and separately you have to remember the properties of ionic and covalent. Right? Again, a question regarding the strong and weak acids, right? It was found that an aqueous solution of the compound Ha contains H plus ions, A minus ions, OH minus ions, as well as undissociated Ha molecules. Undissociated Ha molecules. The pH value of this solution is less than 7. If it is less than 7, it should be an acid butane, right? Which of the following statements is true about Ha? Right? There are H plus ions and A minus ions and OH minus ions, and undissociated Ha molecules are there in the solution. Right? Then Ha is a strong acid. If it is a strong one, there are not be undissociated Ha molecules. Right? Here the pH value is given as it is less than 7. So it should not a base. Then we can cut the answer 3. Right? And it is not a salt. Then we can cut the answer 4 also. Then Ha is a strong acid or Ha is a weak acid. If it is a strong one, there are no undissociated Ha molecules in the solution. So the answer should be the second one to take. Ha is a weak acid. Right? 33. Why is limestone added to the blast furnace during iron extraction? Yes. Why is limestone added to the blast furnace during iron extraction? Yes. Can you remember the iron extraction? It's regarding with the activity series. Yes. 33 people. Right? The activity series. The elements, the metals in the top of the activity series, we extract by the method of electrolysis. Electrolysis of the molten chloride. Molten or the fused chloride today. Both are same, right? Fused chloride. And the metals at the middle, we extract by the reduction methods. By the reduction method. Right? And the metals at the bottom, we extract by using normal, simple, physical method. Right? Physical method. Physical methods, okay, no? Right? The electrolysis process we discussed in grade 11, right? And this part, under the reduction method. Here in grade 10, we discuss about the iron extraction. Right? Iron extraction. During iron extraction, what are the raw materials we use? Yes, what are the raw materials? That means what are the substances we add from the top of the blast furnace? The raw materials. Yes, what we use? As the raw materials, the main one, we use hematite. Right? That is the source of iron. This is the source of iron. We use hematite as the source of iron. Right, under the reduction method, we use iron extraction. Right, there, what are the raw materials we use? Right, from the top of the blast furnace, we add three raw materials. The first one, we use hematite. Right, that is the source of fire. Right? This is the source of fire. And what is, we use coke to take. Why we use coke? For what is the purpose? Yes. Right? That is the reductant we use. Right? To reduce the iron ore to iron. Right? This is the reductant we use to reduce the iron. So we use this as the reductant or to form carbon dioxide. Right? Third one, we use limestone or the calcium carbonate. Right? Limestone or the calcium carbonate limestone. Right? What is the purpose of that one? Right? We use calcium carbonate to remove impurities. Yes, we use it to remove impurities because as the impurities, it forms calcium silicate and calcium aluminate. Right? So we use calcium carbonate to remove the impurities from the iron ore. Yes, what is the answer? The third one. Right? 34. What is the true statement about neon atom and sodium plus ion? Right? I told you that it can be given the questions like this. Neon atom, right? Neon atom, the noble gas, and sodium plus ion. The number of electrons in both is equal. The number of protons equal. The number of neutrons in both is equal. The number of protons in both is greater than the number of neutrons. Right? What is the answer, Buddha? The first one. The number of electrons in both is equal. The number of electrons. There are 10 electrons in neon and sodium plus ion, right? Not sodium atom, sodium plus ion. Protons different, neutrons different. The number of protons in both is greater than the number of neutrons. No, it is same in neon, right? 10, 10, 10, right? So the answer is the first one. Right? Look at 35. What is the pair of subatomic particles which attract each other? Right? Very easy one. Right? The subatomic particles with different charges. Electrons and protons, negative and positive. Neutrons, there are no charge. Right? So the answer is the second one put it. Second one. 36. Right? Which of the following is the molecule with highest number of covalent bonds? Highest number of covalent bonds. There is another question in this way, right? We discussed that one. The number of covalent bonds. 36. Which of the following is the molecule with highest number of covalent compound oxygen? Right, there's a double bond here. 2 bonds are there. Right, in nitrogen, there's a triple bond. 1, 2, 3. Right. Third one, NH3. 1 nitrogen and 3 hydrogen. There are 3 bonds. Right. Look at the fourth one, put a carbon dioxide. Carbon dioxide. Right. How many bonds are there? Yes, here, how many bonds? 1, 2, 3, 4. Here 1, 2, 3. Here 1, 2, 3. Here 2. Then what is the answer? The highest number of covalent bonds, fourth one. Carbon dioxide. There are 4 bonds. Right? 4 single bonds. 2 double bonds. 4 single bonds. Right? Look at the 37. The electronic configurations of the atoms of 2 elements, X and Y, right? X and Y, 281 and 287 respectively. 281 and 287. Of the following statements about the pair of those elements, which statement is false, right? We have to find the incorrect one. Located in the same period in the periodic table. Right? How we find the period number? Yes, according to the number of what put a energy levels. According to the number of energy levels. Here in both X and Y, there are 3 energy levels. Right? Same number of energy levels, so they are in the same period. Then first one, okay. Right? Look at the second one, located in the same group in the periodic table. Is it correct? How we find the group number? That is according to the electrons in the last energy level. 281 means it is in the first group. 287 means it is in the 7th group. So they are not in the same group today. Right? So the second statement is false. We will check the other two. Chemically combined forming ionic bonds. First group and 7th group. Right? Yes, they combine and form ionic bond. That is correct. Combine and form the compound with the chemical formula X and Y. Sorry, XY. That is correct now. Right? In X, the valency 1. In Y, valency 1. Then the formula XY. That is also correct. Fourth one. Then the false statement is the second one. They are not in the same group. Again a question. What is the number of oxygen molecules? What is the number of oxygen molecules contained in 64 grams today? 64 grams. Oxygen molecules, right? $38. What is the number of oxygen molecules contained in 64 2, right? 64 grams. What we know, right? What we know? 42. Right? The relative molecular mass 32 bute. Right? 32. Right? What we know is in 32 grams of oxygen, it contains this number. Avogadro number of oxygen molecules. In 32 grams of oxygen, it contains this number of oxygen molecules. Right? Right? Then they have asked in 64 grams today. Then twice of this one. Then we have to multiply this by 2. 2 into Avogadro number of molecules. What is the answer, Bute? Second one. What is the answer? Second one. Right. Now, look at the 39. Graph is given. Yes. W, X, Y, and Z. Right. W, X, Y, and Z are 4 elements consecutively placed. Right. 4 consecutive elements. Right. That means they are in the respective group. Right. Placed in the periodic table with the atomic numbers below 20. Yes, we have the atomic numbers below 20, right? The graph indicates how their first ionization energy varies against the atomic number, right? So we are given the ionization energy graph. In which group of the periodic table Y placed? Y. W, X, Y, Z is given today. Yes, you have to remember the rough sketch of the ionization energy today, right? When we consider one period, right? When we consider one period, normally we say the first ionization energy gradually increases along a period, gradually increases, right? But there are two gaps, right? If you can remember, right? This is atomic number and the ionization energy, right? When we consider one period, right? When we consider one period, I'm only drawing a rough sketch, right? There's a gap between second and, yes, second and third and fifth and sixth, right? First one, second one. This is the first group, second group, and there's a small gap here, right? This is the third group today. This is from the first group, second group, third group. This is okay for the second period and the third period, right? And then again gradually increases. Then fourth one here and the fifth one here. Again there's a small gap for the sixth one, right? And 7 here. This is a rough sketch, right? And 8 here, right? And when it comes to the next period, next period, yes, what happens? Goes in this way, right? So that is why we say the ionization energy gradually increases, gradually, right? So this is how we can identify the groups. There's a small gap in 2 and 3 groups and 5 and 6 groups, right? So according to this one, Y place, what is the group today, right? W, there's a big gap between W and X, right? W and X, right? So W is in the former period, right? And X is in the former period. X is in the first group, then Y is in the second group. Y is in the second group. So what is the answer today? Second one. Second one, right? Go through the ionization energy graph and the electronegativity graph, right? And you have to remember the definition for the first ionization energy and for the electronegativity and the units, right? And what is the scale we use to get the electronegativities, right? And there are the noble gases are not included in the electronegativity graph. What is the reason, right? And how it gradually increases the first ionization energy along a period, down a group, right? How it happens, those things, right? Question number 40. What is the metal that reacts with hot water, right? With hot water, but not with cold water. But not with cold water. It is an important thing, right? Yes, what is the answer? Magnesium, right? Magnesium, right? We will look at the other answer. Sodium, yes, sodium. It reacts. What is the word we use? We are vigorously, You have to use these words when you write the answers. We don't know how the marking scheme is arranged, right? Normally they give the terms that it should include in the answers, and the marks are given for those points today. Right? Normally, not like in Sinhala or history, we are not writing the lengthy answers like paragraph answers are we are not writing for the science. Right? Only we write the short form or sentence type answers, no. Right? So in the marking scheme, they mention the terms that it should include in the answers. Right? So we have to concern about those things, right? When collecting marks, right? So for sodium, right, the reaction between sodium and water. When we put a small piece of sodium into water, it reacts vigorously with cold water. It reacts vigorously with cold water, right? And it forms sodium hydroxide. When we add uh, phenolphthalein, it turns into pink color, right? Like that, you have to remember all these things. Where we store sodium in paraffin or kerosene oil, what is the reason? To avoid contact with the atmosphere, like that, right? Magnesium, what is the word given or what is the sentence given in the book is there is no observable reaction with cold water. There is no observable reaction with cold water, right? But it reacts with hot water, reacts with hot water. And there's a special thing with magnesium, Bhude. When magnesium reacts with hot water, it forms magnesium hydroxide, right? Magnesium hydroxide. And in magnesium, there's a special thing when magnesium reacts with steam, right? Steam, it forms magnesium oxide. Magnesium oxide, right? All the equations are given in the book, right? Practice to write them. And aluminium, there are no reactions. And calcium, right? It reacts with water, right? So you have to remember this one regarding magnesium. It is very special. The reaction of magnesium with water. With water means cold water, hot water, and steam. Cold water, there is no observable reaction with magnesium. With hot water, it reacts with hot water and forms magnesium hydroxide. And with steam, it forms magnesium oxide. Right? Right? So those are the things that you have to remember. Right? I hope that it is better to stop today, right? Because we discussed up to 40. There are other 20 questions, right? To get the maximum effort, right? It is better to discuss the other 20 questions in the next day today, right? And some structured questions I will send the paper, right? Structured, there are some structured questions from the chemistry part. We will discuss those things in the next day. I will send that paper. So answer that one and be prepared for the next day, right? And I want your ideas that about this part, right? That means the discussing of the past papers in this way, right? Is it good or bad, and what you want to do, right? Right. This is how I explain or how I what the organize, right? If you want to do anything else, or if we have to do any changes in the class, right? Give your ideas, then we can arrange according to comfortable yourself, right? Not me, right? Because you are going to face the exam paper, right? Then we will stop for today, right? I want your feedback today, especially today. I want your feedback. So send a message to the group or send a private message, right? Then we will stop for today. Get ready for the next day uh, when I send the paper, right? And go through the chemistry part again and again, right? Then thank you very much. Good night. Okay. Right, we will stop for today.